So today we'll go to little more basics, like I'll take you to basics. Now this term probability distribution is not new to you. Okay. So we'll go towards basic now. So now tell me, anybody like yeah, anybody has to answer why we study probability distribution first of all. If we study anything, there should be any use, right? Practical use. Otherwise, we are not academicians to study just for academic interest. So my question is, what is the practical use of studying probability distribution? Can anybody
For
answer
decision
that?
making, sir.
Huh?
For decision making by understanding the pattern of the data.
Wow, very nice. Anybody else can give little more specific? Yours is very broad answer. It's right answer, but a broad answer. So can anybody give little more specific answer?
So to predict the possibility of an event happening.
Yes, very nice. This is very specific. So you guys understand, right? So now, like today, let us study some basics. I have prepared today only 13 or 14 slides, and after that, if it finishes early, we'll close early today. Okay? Because I am still in sleep. I'm still sleeping. Okay, so please forgive me a little bit. So don't worry. So we'll study that why we study probability distributions. Okay. So probability distribution help to model our world. It's a very big statement. Probability distribution help to model our world. Means they are telling that it helps to model our world itself. Okay. How? They enable us to obtain estimates of probability that a certain event may occur. Like Sarthak replied, they enable us to obtain estimates of probability that a certain event may occur. Any event may occur, event is going to occur. So our probability distribution, they help to estimate the probability that with what probability this event can occur. See, suppose now a lot of things are going on, like you are reading in a newspaper daily that 2023 is going to be difficult, okay, economically difficult, and a global recession may occur. Okay, so global recession may occur. So they are telling in newspaper, a lot of things are coming. Okay, but nobody knows in this world. Not a super economist will know that whether global recession will come or not. What is the technical definition of global recession? Means any country GDP to continuous quarter if it goes down. GDP, gross domestic product, GDP you might be knowing. I'll not explain GDP. So if any country's GDP for two continuous quarter it goes down, then we say technically it is recession. And similarly, world's GDP, when it will goes down for two continuous quarters, it is called a global recession. Now, I have a question, like everybody has a question, like every CEO, every big leader of a company has a question. What is the probability that this global recession which guys are telling will occur, really occur? Okay, what is the probability? So if some mathematician is able to prove that global recession will occur with the probability of 0.8, 80% or 90%, then we have as a CEO of company, like I have a lot of I can prepare, right? I can prepare my company strategies according to that. So in the recession, companies strategy is different, and when there is a boom, then there is a strategy of the company is different, right? So if somebody can predict that with 80% probability global recession can occur, I can prepare, I can change the strategy of a company, I can prepare my company for that recession, right? So that's how predicting of events which are going to occur in future helps us in taking better better business decisions. So this answer was given by Amit Parikh. Okay. So that if we can understand with what probability future events are going to occur, we can prepare, take better decisions. Okay. So this kind of answer was given by Amit Parikh. So thank you. So thanks Sarthak and Amit. So Probability distributions estimate the variability of occurrence. Like if we predict with what probability event is going to occur, that is means we are estimating the variability of occurrence. Variability of occurrence means with what probability this event is going to occur. Probability distributions are a common way to describe and possibly predict the probability of an event. We have discussed about that. Probability distributions are a common way to describe and probably predict the probability of an event. Like something is occurring, as I explained you, what is the probability of recession really occurring? Okay, so that is called so that's what your distribution help. Now here, right hand side, you might be worrying that sir has read left hand side, but why this figure in the right hand side is given? See here. Now, this particular chart is a very specific chart. Like it's a medical study, and this particular distribution is not exactly normal distribution. You see, the right hand side tail is little longer. It is not exactly normal distribution. It's not perfect bell curve. Okay. So what does it represent? It's plotted for body fat percentage for 14-year-old girls. So they studied only 40, specifically 14-year-old girls, and try to find out their obesity, means try to calculate their body fat percentage. How much percentage fat is there in their body? That's what they tried to find out. And whatever they found out, so like fat percentage they plotted on the x-axis, and probability they plotted on the y-axis. So now if this kind of plot is there, so we have some kind of probability. So this kind of plot we understood is called a probability distribution, right? Right, Sarthak? Have you understood that?
Yes, sir.
Okay, so this kind of plot where like x-axis we have some phenomena like body fat percentage or age or whatever. So some x is there on the x-axis, which is so in this case it is body fat percentage for 14-year-old girls. So that's what we have plotted on x-axis. So flat, it's varying from 0 to 70%. So fat, maybe 70% fat in some bodies, the maybe the highest possibility. Above 70%, there is very less possibility. Very big obesity, so it's not there. So generally 10% to 70% fat. 0% fat also cannot be there because every person has some percentage of fat. So 10% of fat to 70% of the fat they have plotted. And now my question, and the probability of that percentage is getting percentage is plotted on y-axis. So you know that how it is done. So first we plot the frequency, and then that frequency we divide by total frequency to get the probability. So that is called here density here. So we have plotted here y-axis. Now question arises after getting this distribution, any other scientist come who was not involved in this study, he will ask you a question. Guys, you have done this study of 14-year-old girls, you have calculated body fat percentage, and you have plotted a distribution good. Now tell me, what is the probability if I select a random girl out of your group, what is the probability of her being a fat percentage of between 20 and 24%? He's selecting a random girl and he asking you a question. What is the probability of her having a body fat percentage of 20 to 24%? Now you know that what you have to do, you have to find out CDF, right? So lower limit is 20, upper limit is 24. So now this is a continuous distribution or it's continuous distribution or it's a discrete distribution? Tell me. Guys, is it a distribution for continuous number or it's a distribution for discrete number? Let me simplify the question. Is the body fat percentage, is it a discrete number or a continuous number? Body fat
Sir, this
percentage.
is discrete.
Discrete.
No, sir. No. Body fat percentage can be anything. 10.4, 20.4, 30.4, 30.412, 30.43, 40.555, 40.666. I can have infinite numbers between 10% and see lower limit here is 10 and highest limit is 70. I can have infinite numbers between 10 and 40, 70. So it's a continuous number. So here we are dealing with continuous distribution because our x, which is plotted on x-axis, whatever we are plotting on x-axis is the continuous number. So we are dealing here with a continuous number. Okay. So here we'll use sigma or integral. Sarthak. Here we'll use sigma or integral.
Sir, integral.
Okay. So what will be the lower limit of that integral?
So 20.
What will be the upper limit?
So 24.
24. And what will be the fx? What will be the function? What will be the function? So you don't know the function because it is very complex function. It is not a normal distribution function because you can see the right hand trail is little longer. It is not exactly normal distribution. It is something like a skewed distribution. Like it is not symmetric. It is not symmetric about the mean. Right hand side is longer, left hand side is shorter. So it's very complex formula will come out. We don't know what is the formula. Okay, so that formula we have to keep up and find out the area between the curve, the which is the red. Red you can see the shaded in red. Blood red they have shaded, right? So that area will be the probability of a random girl if selected. That is the probability of girl. That girl may have a fat percentage between 20 and 24%. So this area, so that area is calculated as 0.1864. Is that understood, guys? Amit, Jignesh, is it understood?
Yes, sir.
Yes.
Yes, sir.
So what is the use of probability distribution? So this is a particular real life example we have seen. So that's how they have modeled body fat percentage. They have modeled it, and now they are answering practical question. Practical question is what? What is the like random girl if it is selected? What is the like? How much is the probability of her having a probability of having probability having 20 to 24% body fat? So you just find out the area under that curve and you get it. So area under that curve is 0.1864. So 18.64% probability. Okay. So this is a study like government does this kind of studies. Like medical bodies do this kind of studies, right? So now next one more practical. See today's lecture we could have done before starting normal distribution. But in juggling PPTs, some confusion occurred and it slipped into next lecture. Okay, anyway, so now we'll complete it. So one more example of couple of more examples we'll take. What is the use of distribution? Okay, in finance, how it is used. In finance, by estimating the chance that a given financial asset will fall between a specific range. Financial asset mean you guys are here we have couple of Gujaratis, right? So Gujaratis are very great at stock trading, right? Most of the moneyed people or wealthy people in stock trading are Gujarati guys. So you understand it very well. If I see instead of this body fat percentage, if I plot stock price. So I take stock price of say Reliance on x-axis and probability on y-axis. Okay. So like probability, like what is the probability of what is the like if I come to know that tomorrow there is a 90% probability that stock price of Reliance will fall by 500 rupees. Will you not sell it off? Is it not helping you in for taking financial decision? Now, if I tell you by such kind of probability model that tomorrow the price of Reliance is going to increase by 2000 rupees, will you not buy that share? Is it not helping?
It's
Financial
helping, sir.
asset here means we are talking about stocks, right? No. So if I
Yes.
can model any stock or any financial asset with the help of this probability distribution and come to know that there is a 500 rupees chances of getting fall. There is a fall in tomorrow. So I'll sell off. And if there is a rise tomorrow in share, I'll buy more shares, right? So is it not helping? Now we advertise. Now let us see how it helps in advertisement. Probability is used to estimate potential customers that will be most likely to positively positively react to a specific campaign based on consumption pattern. Okay, so now like everybody is like all guys are living in a corporate world, so we understand what is a advertising campaign. Also, whenever a new product is launched, they do some lot of advertising about that product in newspapers and TV and maybe in social media also in Facebook also. A lot of they do a lot of advertisement. Okay, so advertising is always targeted advertising. It is not like they don't do advertising for entire say 1.4 billion population of India. They don't do like that. The population like advertising is always targeted advertisement. They do either to a lower middle class people. They do it is either it is targeted to middle class people or it is targeted to higher middle class people who are having more income, monthly income. Okay. So how they decide which segment of the society to target? So based on their past data and their product name, nature of their product. Suppose product is a upmarket car, upmarket Mercedes car. Upmarket means it's a very costly Mercedes car. So tell me which segment of the society they will target, like higher class, higher middle class, lower middle class, and so they will target rich class, middle class, and lower middle class. Which class they will target for a Mercedes advertisement?
Higher class.
Higher class, right? Because it's a very costly product, only rich person can buy it. Okay. So this kind of modeling, like the person, like the customer, the model customer, that this is they model the customer, the model customer this way. So how the customer who are likely to respond, they plot on x-axis, and the customers they plot on x-axis, customer segments, and their probability of their responding to this ad is plotted on y-axis. So like that, they model this kind of customer behavior, and based on that, they take decisions for which customer to target. That is one more. So this is the first statement. What we did, probability distributions help to model our world. Model our world itself. We have made a very big statement. Probability distribution help to model our world. So anything, any damn thing, which is a variable, which is uncertainty, there is some uncertainty of occurring, you can model with the help of probability distributions. Okay. So now here let us take one more example. So like there is a blood group of like we are 4 5 guys here in this class today. So everybody may have a different blood group. So suppose Sarthak has O group, O positive or O negative, Sarthak, and then Amit has A group, then Jignesh has B group, and Karthik has AB group, blood group. Okay, so that's how it is. And probability of getting that blood group is O there is a probability of 0.3, 30%. A there is a probability of 50%, B there is a probability of 15%, and AB there is a probability of 5.5%. So now if I plot this blood type on the x-axis, O, A, B, AB, I plot on x-axis, and probability of finding that is I plot on y-axis. Is it not a probability distribution? Is it not a probability distribution?
Yes, sir.
Okay. Now based on that, if I ask you a question, which blood is most difficult to find? Which blood is most difficult to find
Sir,
based on this
AB.
data? Can you tell me that?
AB.
AB, right? Because only 5% people have that. According to this data, I'm not telling it is true for our society. According to this data, AB is most difficult to find because only 5% of getting that blood. Which is blood you can get most easily, most commonly,
Sir, A.
right? So based on that, will you like if you are a blood bank manager, will you stock AB blood more or A blood more?
Sir, AB.
Stocking which blood you will stock more? If you are a manager of suppose you are a manager of a blood bank, which blood out of this four groups, which one you will stock more?
Sir, AB.
Why you will stock AB more?
So because chances of finding that is less.
Less, right? So is it not helping you in taking a decision, business decision? So you will whenever you find AB person with AB blood group, you will maybe you will pay him 500 rupees extra for a bottle of blood. 500
Sir,
rupees. Yeah, tell me.
sir, will stock A group more, na? I mean, that will require for more people. I mean, obviously, we'll ensure to stock this AB group, but the requirement for A
So
will be
that is
more.
another. So you are representing another point of view.
Okay.
So from like shortage angle, you will stock AB more, and for AB you will stock more because AB will stock more because it is required for more number of people. But we are not talking about general population right now. We are talking as per this data. So as per this data, generally speaking, the blood which is rarely available, you will stock it more, right?
Oh, yes.
There are two different angles you are giving. Both Sarthak is also correct and you are also correct. So it is two different angle you are giving. So if I ask you from the angle of shortage, from the angle of finding the blood, which blood you will stock more? So that is AB. And you are also right because AB requirement is more. AB requirement is more, so you will stock AB more. But AB is easy to find here. Any damn guy you pick up from the street, his blood group will be A only. Generally, the more blood group is O in practice, I think so. O positive and O negative, I think rare. But O positive is more common, I think so. I'm not a doctor or I don't know.
Yes. Yes,
So O
sir.
positive is very easily available. So like there are many NGOs like in a non-government organization who go organize blood camps. So according to this data, out of that 50% probability of getting A blood, according to this data. Let us concentrate on this data only, okay? So any like easily you can get. So why you will stock here? Like I'm having less A blood today. So tomorrow I will just organize one more blood donation camp. So I will get lot of A blood because 50% of people are having A blood. So it is easy to find, right? But AB only 5% people have. So I'll stock it more. Maybe a person, if I get with AB blood group, I'll pay him 500 rupees extra for a bottle of blood. And I'll encourage him to give more blood. Okay, within medical limits only we can take blood. So I'll encourage him to give 2 bottles of blood. Maybe I'll give him 500 rupees extra. I'll give him some more incentive to give more blood and I'll stock it more. Okay. So that is how we are modeling like simple blood donation camp. And is it not helping us? Is this data, is it not helping us in taking business decision? Is it not
Ye-
helping us?
Yes, sir.
Okay, so this is the one advantage. So now now tell me here we are modeling it. This is a discrete distribution or that this is a continuous distribution?
Sir, this is discrete.
Why this is discrete?
Sir, because we are only limited to 4 blood groups.
Yes, you are right. So blood group only O, A. So if you number them, O is 1, B is 2, O is 1, A is 2, B is 3, and AB is 4. Only 4 numbers are there. So this is discrete modeling, right? Yes, we are modeling discrete number. Now, probability distributions in real life, lot of probability distribution model exists for different situation. Okay. So here you saw two situations. Here, one was body fat percentage. It was a continuous distribution. It was a continuous distribution. This is one type of distribution. Here, right hand tail is more long. So it is a skewed distribution. This is one type of distribution. Now for blood group, blood group, this is one type of distribution. So there are number of such distributions. Now tell me how much will be the if I add up all the probabilities, how much it will add up to?
Sir, 1.
1, right? Now tell me another question. What will be my probability of getting a blood of either O, A or B? Either O or A or B. What is the probability?
1 minus AB.
Yes, right. What is my probability of getting either O or A? Only I am talking about two. Either O or A I should get. What is the probability? Either O is also okay and A is also okay. What is the probability?
So probability of O plus probability of A.
Yes, right. You now know that, right? You have to just add up. So 80%. So getting O is 30% or so that is we are talking about CDF now, right? So if I am talking about O and B, so that is CDF. O and A also that is CDF now we are talking about. So you have now learned to solve basic problem of probability. So all this add up, if you add it up, it will add up to 1. Okay, so that is so now here also. Now, if entire area of the like under the curve, if I take up, it will add up to 1, right? So this is continuous distribution, and this is your like discrete distribution. So this is continuous, and this is discrete. But all the if you take up all the probability. Now here, what is the sample space? Tell me here in this case, what is the total sample space? Tell me, what is the sample space here?
Sir, 4.
Total, yeah, you are right. 4.
Sample
O,
size.
A, B, and AB. Total sample spaces. So all sample space means all the all the cases. So cases are only 4, O, A, and B, AB. O, A, B, and AB. Only 4 are there. So sample case here. Now here in this case, what is the sample space? Total sample space. Amit bhai. In this case, what is the total sample space?
60.
Yes, 70 minus 10, right?
Yeah.
So now I think at least basics of probability you have picked up, which is good. Okay, so now we go ahead. And as I said, there are a lot of probability distributions available. This curve can take any shape, no? This curve can take any shape. So if curve shape is different means your formula is different. So that means there can be many probability distribution to model different kind of situations, different kind of phenomena. Okay. The key point is that you have to select the right one to that fits your data and helps you explain what you are trying to understand. Now here we are using one type of distribution. So maybe we name it a skewed distribution, right skewed distribution. So we are using a right skewed data. So this is one. So this is where here we are trying to model body fat percentage of 14-year-old girl. So here we have chosen this distribution. Now here we have a simple distribution which is kind of bar chart, and this distribution is for discrete number for blood groups. So like now tell me if I have some data like this, some data is there, table is there, a data table is there. On x-axis I have some variable x, and on y-axis I have its probability. I have only a table, but I don't know which kind of distribution it belongs to. Then how you will choose? See, on x-axis I have any x variable, and on another column I have data which probability is given. So you can how you will choose generally speaking? It's a natural phenomena. Suppose probability of getting rain in Bangalore for next probability of getting rain in Bangalore for next 14 days. So days I am plotting on x-axis, and probability of getting rain I am plotting on y-axis. So you have day number 1, day number 2, up to day number 15 on column 1, and probability of getting rain in column number 2. Now, how will you choose which probability distribution it belongs to? Which probability distribution? Though we have studied 3 so far. So we have student T, we have studied. Then we have studied the normal distribution. Then we have studied uniform distribution. Suppose out of 3 only, how will you select? which to choose to model, which probability distribution to choose to model this? How will you choose out of three? Because we have studied only three. That's why I'm asking only three options are there. Rain number of days are there. So day number 1, day number 2, day number 3, up to day number 15 on column 1. And in column 2, probability of raining 90%, 80%, 40%, 30% on y-axis. So all probability are adding up to 1. All probability, if you add up, they will add up to 100% or 1 or 15 days, next 15 days. Which phenomena you will choose out of normal distribution, student T distribution, and uniform distribution? Which one you will choose?
Student T.
Student T. Why?
Sample space is less.
Wow, great, Mr. Jignesh. You have won the race. You have won. Yeah, number of samples are less than 30. So we are will choose student T distribution, right? So like that you have to choose. So that means you have some data. So based on that data, you have to choose right distribution to model it. Now you understand. Here we had rain data, day and rain. We had rain data. So out of that, you have chosen student T distribution to model it. Now you have student T, then you have T table are there, and all those things were not, those numericals were not solved so far. But once you know how to solve, how to read T table and use it and all that, so you have modeled that phenomena, right? Yes or no? Amit bhai,
Yes, sir.
if you know it is a student T distribution, you know a lot of things about it, right?
Yes, yes.
That's how you have to choose. So today we are going to discuss only basics. So in simple terms, probability distribution model is a guide you use to fit random variable in order to generate its behavior. See, there is a random variable. So see here, rain. Percentage of rain is a random variable. Okay. So number of days, so any random variable. So here, in this case, what we are modeling? What is random variable here that we are modeling? In this case, what is the random variable that we are modeling in this case?
Body fat.
Body fat, correct. So here random variable is body fat, that's we are modeling. Here in this case, what is the random variable that we are modeling?
Blood group.
Blood group type. That's what we are modeling. Okay. So generally speaking, this definition is, in simple word, a probability distribution model is a guide you use to fit a random variable in order to generate its behavior. See, read the first bullet. So you are modeling a random behavior to understand its behavior. You are modeling a random variable to model its behavior. Okay. Have you read? Has everybody read the first bullet? Is it understood? Karthik bhai?
Yes, sir.
So basically we choose a random variable and we have some probability related to that random variable. So when we used to understand what is the behavior. So we can model it either with the help of normal distribution, you can model it with the help of student T distribution, or you can model it with the help of a uniform distribution. Okay. So there are many more models. There are many more distributions available with the help you can model. So you have to choose appropriate one, which is applicable in your case. Okay. So why do you take? So like next question is, why do we take care about it? Like why do we want to understand the behavior of a random variable? So you are telling, I want to understand the behavior of a random variable. That's why I'm modeling with a probability distribution. But any child will ask you in a question in the class, what? So sir, you want to understand behavior of a random variable, but why you want to understand the behavior of a random variable? Okay. So now answer is given in the next bullet. Try to read with me. Because the type of random variable is a key parameter. Type of random variable is a key parameter when defining the probability distribution model, right? That random variable is the key parameter. Key parameter means there can be many more parameters, but it is one of the key parameter, one of the important parameters. There can be many parameters, but it is one of the key parameters while defining which probability distribution model you should choose. Like random variable is the key parameter which will decide that what kind of distribution you should choose. Right here random variable was body fat percentage. So you chose the continuous type of distribution. Okay, here your blood group were type were limited to 4, so you chose a discrete type of distribution. Okay, so like that, based on the behavior of random variable, you will choose the distribution. Okay, so now next we are going into discrete and continuous variables. So you understand discrete, what is a discrete variable, what is a continuous variable. So many times we have discussed it, so you understand it now. Okay, now next, I want to skip this population sampling and see. So now for discrete variables, there are two for discrete variables. There are two probability distributions which we are going to study tomorrow. One is Poisson distribution, one is binomial distribution. They are very simple. Don't worry by the name. Poisson is the name of the inventor of who invented the distribution, and binomial distribution is a type of another type of distribution which are applicable for discrete type of distribution. Now, similarly, for continuous type of distribution, there are two main distribution. One is normal distribution and one is uniform distribution. Both we have already studied in previous classes. So you very well understand normal distribution. We had taken 2 classes on it. You understand uniform distribution. We have taken 1 class on it. Okay. So now you understand that. Now you tell me, if I toss a coin, so that will come under normal distribution or uniform distribution?
It will be discrete.
Discrete distribution. So like, okay, but let us assume it as a continuous distribution. So like I will choose normal distribution or I will choose a uniform distribution to model it.
Uniform.
Uniform, right? Jignesh bhai is giving one after the answer other. Yeah, Jignesh bhai, champion. Okay. So now I am giving you one more example, discrete distribution. Discrete distribution, like this plot, understand, right? Between this plot, I don't have the slide handy, but I explained you like how to plot this left hand side. Like random variable varying between say 1.1 to 1.2, 1.5, 1.1 to 1.5. How much is the frequency? That I'll plot with a smaller one. Then 1.5 to 1.8. How much is the frequency? 1.8 to 2.1, how much is the frequency? Like that, different range I will take and plot the frequency. You got how left hand side plot is plotted? 2.5 to 2.33 range I am taking. 2.5 to 2.8. How much is the frequency? Once I have frequency plot, I can very easily convert it into a probability density plot, right? Or a probability PMF or PDF, I can very easily convert. Got it, na? How to convert a frequency plot into that? Simply, if I draw a smoothing curve, so I'll get a right hand kind of curve. So if I join the middle points of all the bars here, middle points of all the bars, if I join, I'll get this right hand kind of curve. So this is a normal distribution. See here, the left hand side, when we talk about 1.1 to 1.2, 1.2 to 1.5, 1.5 to 1.8, 2.5 to 2.8, like that we have plotted bar 1. So that is nothing but you are called a discrete kind of thing. We are plotting discrete things. Okay, discrete thing we are plotting. Suppose, let us take a better example. 1 to 4 I have plotted here, 4 to 7 I have plotted next, 7 to 10 I have plotted next, 10 to 13 I have plotted next, and for every range I have plotted the frequency. So this is a discrete distribution. So in this discrete distribution, we know that it is called probability mass function. When we plot a left-hand side kind of plot for a discrete function, it is called probability mass function. And in this, the important variable are count. Count is the important variable, sum is the important variable, and proportion is the important variable. Then our then we know CMF and PDF. So we have another things are we calculate sum and difference. So simple things here are more important, kind of count, sum, difference, proportion. So simple things are more important in case of PMF. And in PDF we have continuous range. So continuous range, continuous range, you know that you handle with the help of integration. Okay. So like here we take a difference. Now here instead of difference, we have to use differential calculus in continuous function because your probability function, probability density function is always represented by a relation like y is equal to x square. So where x is your random variable and y is your probability. So y you will plot on y-axis and x you will take on x-axis. So y is equal to x square. So this is the kind of relation you will get in the case of probability distribution function. So like if you have to find the probability distribution, like here, like if in this case we have found out here, right? Here. So here in this case, suppose you have to find out what is the probability between 20 and 24, modified percentage between 20 and 24. So here you have to use integration of lower limit 20, upper limit 24, and then you have to put the formula for PDF, probability density function, and then you have to integrate between 20 and 24. Okay. So this is more important. This is more important in the case of a continuous distributions. If you ask mathematically, they are little more challenging to handle because they deal with a little bit calculus and differential calculus will come, integral calculus will come. So they are little more. Continuous distributions are little more. The formula will be complex. The formula you have seen the formula for continuous distribution. So this is kind of complex only. It's not easy formula. So formula for generally continuous distribution will be complex compared to discrete kind of thing. So in discrete, important variables are count, sum, proportion, difference. So so here when you are doing sum, so here you will do integration. If you are doing difference here, instead of that, you will do differential here. Okay. So that is what a little bit difference between discrete and continuous functions. Now here we are discussing one example of a discrete distribution in real life. So discrete distribution we are discussing. So after tossing a coin 10 times, a coin, this lady you see is tossing the coin 10 times. We can plot the probability count of heads. 0 head, 1 head, 2 head, 3 head, and 10 heads. So we are taking probability count of 10 heads, number of heads. So in 10, there are only 10 experiments. 10 times I'm throwing. This lady is throwing only 10 times. So how much is the probability out of these 10 experiments? What is the probability of getting 1 head or 2 heads or 3 heads or all the 10 heads? So 0 head probability will be very less. 0 head, because there will be at least 1 head will come only, right? If I toss 10 times, probability that 1 or 2 heads I will get, or maybe 3 or 4 also I will get. But all the 10 heads, is it a probability? I'm throwing randomly 10 times. Can I get 10 heads? Can I get 10 heads in that experiment? What is the probability? Karthik bhai? I'm throwing a coin 10 times in the air and asking you a probability. All the 10 times I should get head. What is the probability? Is it less or more?
Less.
Less. What is my probability of getting 0 heads? It is less or more?
Less.
What is the probability of me getting 4 or 5 heads? Is it less or more?
More.
More, right? So that's what we have plotted here. So we have plotted number of heads on the x-axis. That is our random variable. Random variable is number of heads we are getting. That is random variable, and its probability we have plotted on y-axis. So this is one of the example of discrete variable. Okay, so discrete distribution. Okay, so now continuous distribution. Now height of a person, if I take height of a person, is it a discrete function or a continuous function? Height of a person,
So continuous.
continuous function, right? It can be anything like 150.1 centimeter, 150.11 centimeter. If I measure it precisely, 160.21 centimeter, like that, it can take any number. So if I say height of certain group of people, I taken a group of people, random group of people, which is varying between 150 centimeter and 200 centimeter. So 150 centimeter guy is the shortest guy, and the 200 centimeter height is the tallest guy. Now I'll ask you a simple question. You said, Karthik, Sarthak said, it's a continuous distribution, which is right. Now I'll asking how many numbers are possible between 150 and 200? Jignesh bhai, how many numbers are possible between 150 and 200?
Yeah, 50.
No, how come 50? Na? We said just now we discussed is the continuous number.
Yeah, it's we can say infinite like that. No?
Infinite numbers, right? I can have any number of decimal points, right?
Yeah.
So it is infinite numbers. So such variables when I plot, see now I have taken say 200, I have taken 200 people. Okay, so number of the person I have plotted on say taken on like height I am plotting 200 persons I have taken in the group. 200 persons I have taken from in a group. So if I measure height of those persons, how many height numbers I will get? I have 200 persons. I have measured their height. So how many height numbers I got after the
200.
experiment?
200.
200 number.
Yes.
That height I have plotted on x-axis. So height is my random variable. So it is varying from 100 to 150, 200. And then I did first frequency plot. What is the range? In this range, how many people were there? 150 to 160, how many people? 160 to 170, how many people? 170 to 180, how many people? Then 180 to 190, how many people? Then 190 to 200, how many people? Like that, I've got a frequency plot. So if I do a frequency plot, I will get a figure, I'll get a bar chart like this, left hand side. When I draw a smooth curve on the top of bar chart, I'll get a distribution like this. So which kind of distribution is this?
It's a normal distribution.
It's a normal distribution, right? So here we are measuring height of 200 random people and putting height on x-axis and probability on y. The probability of getting that height is on y-axis. So we get a normal distribution. Okay. So this is one of the example of normal distribution. And generally, our normal distribution, generally our any natural phenomena, like any natural phenomena, social phenomena, when we plot now, generally we get normal distribution on. It is a wonder, statistical wonder. You measure height of 150 persons in India or a height of 200 people you measure in India, you will get a normal curve. You made height of 200 random people in US, you will get a normal curve. But US people height the range might be different. So range might be from 150 to say 210 or 220. Okay, I'm just giving an example because US generally average height of US people generally speaking is taller than India. And if you take the same 200 people in Japan, it will also be a normal curve, but range will be different. So range may be 140 to 190 because Japanese people generally height is less compared to Indian people. Like that, your range might be different, lower and upper range might be different, but still you will get a normal distribution curve. Is it not a wonder? It's a mathematical wonder, right? So generally random Generally, you are speaking your natural phenomena, like many natural phenomena or many social phenomena, they generally they take the shape of random curve only. Like this, if you plot them, a plot comes out like a random curve. So suppose now you have done suppose a social experiment. Social experiment means I give an example like you are working in say washing powder company. Washing powder company you are working. Random example I am taking. So you are working in a washing powder company and you have surveyed 500 people, 500 homes. Your random home you went, random houses, 500 you have chosen, large number, 500. 500 you have chosen, and you have found the average monthly consumption of washing powder. Some people will say my average consumption monthly is half a kg. Some person will say mine is 600 grams. Some person will say mine is only 400 grams. So like that, if you plot. Now on the one column, only you have two columns now. In one column, you have say you have say the consumption of washing powder between lowest value suppose is 150 grams, highest value is 750 grams, like that. So 150 grams to 750 gram, you have the data, and then you have done binning. Binning means then you have found out like 150 to 200, how many houses are there? 250 like 150 to 100, 150 to 200, how many? 250 to 300, how many houses are there? 250 to then 250 to 300, how many houses are there? Like that, you have plotted a frequency plot. Frequency plot will come like this, left hand side figure. Now, after that frequency plot, you find out the probability and draw a smooth curve. So it will come out like this. So now tell me, before drawing the smooth curve, you are a statistics guy. Statistics guy. Your people will ask you which particular distribution you will use to model this experiment. Like I went to 500 random houses and measured their monthly washing powder consumption. So now your manager is asking which probability distribution should I use to model this kind of experiment? Tell me. Without plotting, he is telling you. He doesn't want to plot. He doesn't have time to plot and all that. He doesn't have patience to plot. Now he is asking you as a like statistics guy, that which phenomena should I take to model this particular thing? Tell me. Which one you will choose? Jignesh bhai, you want to answer? Or anybody? Sarthak, Amit, Karthik, anybody? Which like I'm giving you three options: normal distribution, T distribution, student T distribution, and uniform distribution. Which one you will choose?
Uniform distribution.
Why uniform?
So
Will that like if I say 150 to 200, 150 to 200 and 250 to 300, 150 to 200 and 250 to 3 see, let us take two buckets, 150 to 200 gram consumption and 150 to 200 and 200 to 253. Will that number be same? If I say I take two ranges, my x-axis is between 100 and 150, 100 and 150. Next I'm asking, my next bar is 150 to 200. If I count number of houses which are consuming between 100 and 150, and then I also count between 100 and 150 and 150 to 200, will that number be same?
100 to 150 and 150 to 200, that will be same.
How come it will be same? Yeah?
100 to 150, I mean the range is the same.
Range is same, but the number of houses which are falling in this range, will it be same?
No, that will not be same.
So then it cannot be a normal distribution.
Yeah.
It cannot be a uniform distribution, right?
Yes.
If I convert that frequency plot into probability plot, it will be different, right?
Yes.
So it cannot be a uniform distribution. Now tell me which one you will use.
It's a normal distribution.
Why normal distribution?
So because the sample size is high
Yeah, sample
and
size is higher. That is one thing. Sample size is okay. High is higher, one thing. But another thing is
in that
when generally you have more than 30 samples and you are modeling a phenomenon like this, like consumption of washing powder or height of a person or those kind of things, if you are modeling generally, we take it blindly, we take it as a normally distributed. Okay. If number of sample size is more than 30, we blindly take it. Generally, we take it like 80%, 90%, or maybe 100% will model it with the help of normal distribution. Got it? Because generally, this kind of phenomena are known to follow normal distribution. So suppose you have some data and your sample size is more than 30. And if it is belonging to some social phenomena or natural phenomena or something like which is very random, you can very easily, very safely take a normal distribution to model it. Got it? Got it, guys?
Yes, sir.
Yes, sir.
Yes, sir.
Any phenomena where you think is a random phenomena. See, consumption of washing powder in a different houses is very random. Somebody can use X number, somebody can use X plus 1, 150, somebody can use 250, somebody can use 250.5, like that. Is it not a random number? Nobody controls it, this number, right? Every house washing powder consumption will be different. It's random, right? Right? Yes or no? Yes or no?
Yes, sir.
So any random kind of any phenomena which you think is a random kind of things, very safely you can go for normal distribution. Just don't think anything. Model it with the help of a normal distribution. And if sample size is less than 30, use T distribution. That's all. Very simple. Okay. So now now it is 1 hour already. And also I today plan to take up only basics like this. So now tomorrow we'll start with a specific discrete distribution which is called Poisson distribution. So that is tomorrow's topic, Poisson distribution.